So now that we know that white light is composed of the various colors of the rainbow, it makes us wonder what actually gives light its color? Well, the answer to this question is the wavelength of that light. One wavelength is the distance between two consecutive crests or peaks or troughs in a wave, and we usually represent this as a variable using the Greek letter lambda. We allow ourselves to call the wavelength of light a variable because it varies. Certain types of light have certain wavelengths, which we'll see more of a little later. So, how do we remember the relative wavelengths of visible light? Well, we can always refer to Roy G. Biv, the acronym that's familiar to us as the colors of the rainbow, which makes sense considering that we now know how closely light and rainbows are intertwined. But the light we can actually see has a very specific range of wavelengths between 400 and 700 nanometers. Since we usually represent ranges of values from small to big, well, at least here we've done this, why don't we flip Roy G. Biv and remember this new acronym, VibGyor? At least this way, we've lined up the short wavelengths and the long wavelengths with the corresponding limits on the range of visible light. But what are these units when we talk about light? What are nanometers? In order to understand nanometers, let's start with the meter. In just 1 meter, there are 100 centimeters if you break it down into 100 equal pieces. But if we broke it down in even smaller pieces, say into 1 billion pieces, then each one of these tiny slivers would be 1 nanometer. So 1 nanometer is 1 billionth of a meter. And this can be represented in decimal form as 0.000000001 meter and as a power of 10 as 10 to the power of -9 meters. But each of the colors have specific wavelengths associated with them. Violet is around 400 nanometers. Indigo, or what we call royal blue, is 425. Blue, our baby blue, is approximately 470 nanometers. Green is 550, yellow 600, orange 630, and finally red is 665. Darker reds can go as far as, if not a little bit past, 700 nanometers, but this is the overall range. So let's test this idea. Which wave is orange? Is it the first, second, or third wave? Well, the problem here is that it's kind of hard to tell without more information. We don't actually know whether this is red or green, or if this is actually yellow or blue. So, how can we place which one is orange? And what if this is actually the red wave? Then what are these two that have longer wavelengths than red? How are they classified? Do they even have a color? Well, stay tuned to find out in the next video where we'll jump into the electromagnetic spectrum.